Yeah, I would like to, first of all, finish the topic about observer versus event-driven design. Again, as usual, let's recap what we have done last time, okay? So this structure over here, which is rather complex, which we discussed on Tuesday. So this will be the runtime structure for observer pattern. So the observer pattern, which we studied the code already about in IFO last time, so you can refer to the notes. So this is really too complicated to really handle some general case where you have multiple subjects and multiple observers. So that's not the way to go, okay? You'll see if you have exactly, let's say, if you got, let's say, n observer, so m subjects, and also you got n observers, the complexity will simply be m times n. Okay, that's just too much. Okay, now what we will do is we're going to say we're going to move on to this particular structure, okay, which is called event-driven design, event-driven. For every so-called monitor variable that we want to monitor for the observer, we're going to declare a type called events, okay? And then every time if you want to observe certain variable, you will simply get, for example, subscribe to a particular event, right? And every time if the subject has any updates, they'll simply publish rather than directly to the observer, they're going to publish onto the events. Okay, that's the overall picture for the two paradigms. One is just the observer pattern, which we do make use of polymorphic array, dynamic binding, etc. But the second one is actually even better. You can reduce the complexity of the links at the runtime. So there's something I would like to highlight, which is really important between the two designs. Remember last time we talked about something called pointer to function, right? The idea. So why do we really need this for the case of the event-driven design? Let's just review. In the case of the observer design, okay, which is rather complex, let's think about what's going to happen whenever there's an update. If there is an update, let's say for this particular subjects, let's recall what's going to be the consequence if there's an update on the particular subjects. The subject is going to say, well, because I have a list of observers that I maintain, and each observer can be either statistics, can be forecast, can be current conditions, right? What I need to do, I should really follow the link and go to every observer that has subscribed to myself. And then I'm going to explicitly call the updates method or feature on each observer, right? Whenever there's updates, I'm going to call the update feature of my observer directly. Okay, that's for the observer pattern. But now, if you look at the event-driven design, there is an intermediate level that we are introducing. That's really the key for reducing the complexity of the runtime links. But now, whenever there is an update, let's say for this particular data, we cannot just directly call updates on this observer anymore. There's no such link, right? That's how we reduce the complexity. So what we should do now is to somehow have a way to have delay execution. To say for each observer, when they try to subscribe to this particular events, not only that they have to pass their identity to the events, but also whatever updates function they have, conceptually you can think about when they subscribe, they have to pass the address of the update function they have. Okay? So it's delay execution. So it's actually stored at the events over here, and then whenever you want to publish an updates, what you will do is, I will simply go to the events, and I will call this particular update that's being stored, that's being delayed. Okay, that's the fundamental difference. Okay, just keep that in mind. In the observer design, you can call the updates directly right away. However, in the case of the event-driven design, you let the observer to delay the execution of their updates and store that in the event side, and then call that later when necessary. Okay, so that's the fundamental difference between the two. Yes. Does it involve any create behavior? Create.
Operating system, assign priorities to the process.
Let's not worry about the process level. That'll be up to the scheduling for the operating system. We only talk about design, right? At the design level, all you have to do is, whenever you want to subscribe this particular observer to the events, you have to make sure you pass the identity for the observer, and also you pass the reference to the update function. You don't really call the update. You pass a reference, so the execution is delayed. Okay? Yeah. Okay. Now, I'll try to explain, summarize very quickly. I know that's a bit too small. Let's see if this might work. Okay, is it visible? Good. Let's just review how we do this in Java. And then the idea in iPhone will be exactly the same. Nothing is new in the idea. It's just that at the syntax level, they have more direct support about passing the pointer to a function. That's the only thing you have to be aware of. Okay? Now, let's see. This is our take for the event-driven design in Java. Okay, let's see how we do it. We already went through the code last time, but let's just recap very quickly. Okay? So now at the event level over here, let me just use maybe blue over here. At the event level, okay, that's a basic level. So for every event, whenever you want to subscribe a particular observer, you have to make sure you got their identity and also you got a reference to their method. So method handle over here is simply just a library class I used for storing the reference to a method. Okay? And then we also got subscribe and also we got publish. Okay? What does a subscribe do? We simply put into the observer list. And for every observer, we simply call a listener, the identity, and also the action we have. And then whenever there's any publish of the updates, so what we will do is we're going to go over all the listener in this particular list. Okay, go over them. And then for every one of them, we'll simply say action has been delayed. We only store the reference to it when we first subscribe the particular observer to the events. Call that with the particular arguments which we pass over here. Okay? That's kind of the big picture for this event class. Okay, any question at the event level? Okay, let's move on to the next level. Yes?
Can you just quickly explain again why we have to delay?
Why do we have to delay the execution of the action? If you look at, it's a really important question. If you look at the design over here, right? Again, if you look at the observer over here, let's say whenever there's any updates over here from the subjects, right? What you can do is I can go over the list of observers I have maintained and I simply call the updates on each one of them. So there's no delay. I only do it when I have updates. Okay? However, this is simply because every time when you subscribe for an observer, you subscribe directly to the subjects. That's why I got a direct link to the observer. Now, to reduce this kind of complexity, we introduce this intermediate level over here. So there's no direct subscription from the observer to subjects. So that means between the subscription and updates, there might be quite a long time before the update occurred. So when you first subscribe the application to the events, you don't have to call the update just yet. There's no need just yet. So all you do is you pass the identity for the observer, and also you pass the reference to the updates. So it's delayed, right? That's okay, guys. Again, it's really important to realize why we need delay execution of the updates for the event-driven design. Okay. Now let's go back there. So now we have done the events. Let's go to the subjects. Okay, weather data. So for the subjects over here, we got temperature, we got pressure, we got humidity, right? These are the three data. And also, we also got three events over here, right? The intermediate events, which we declare at the subject side, okay? And for every event, we simply have the naming convention, change on temperature, change on humidity, and also change on pressure, okay? So just new events. Now, every time if there's any updates on the measures for the weather data, so we simply say as part of the set measurements, not only that we're going to update the temperature, humidity, and pressure, we also have to publish the new values to the events, right? So that means we're only going this way. We're only going from the weather data over here to the events. Nothing has occurred just yet to the observer, okay? Okay, good. Okay, let me go back here. Okay, let me just make sure. Okay, that's about the weather data. Any question about weather data? That's the subjects. Okay. After this, let's look at how the observer can be defined. Okay, let's just show one example there. Now, for observer over here, for example, current condition over here. Okay, I'll make it a little bit bigger. Okay. Now, for example, one of the update operation we have is to say updates temperature. So this means whenever we want to subscribe this particular current conditions observer to the events, we don't really call the update temperature right away when we subscribe. We only pass a reference to this particular method to it so that its execution is delayed and will be done later. Okay, that's really the key. And now, in Java, it's actually quite verbose to actually do so. Okay, the idea is easy. The idea really is we're going to use the method handles library class. You can go to the API and look it up. Okay, basically what I have to do is whatever method handle I'm looking for this particular method, I have to call some method called find virtual. Okay, you don't have to memorize the name. I'm just trying to show you this is what you have to do in Java. So you have to pass the class for the method and also the name of the method and also what's the type of the method. For example, the method will be just a mutator, so it returns void. And also it takes just a single double. As you can see, the single double being taken for this particular method, right? Okay, so once I find this particular method, I'm gonna get a handle. Let's call it UT. Okay, and then now when I try to subscribe this particular observer to the, let's say this particular event, let's say change on temperature, I need to pass the identity for the current objects for the observer and also need to pass the delay reference for the method, right? Okay, and similarly, we also do the same for update humidity, okay? And now, are we okay so far? Okay, and now let's go on once more. Now, what we have to do now is to see exactly, this is the final class we have to look at to see how the chain effects actually occurred. Basically, I want to show you two lines of the method call. We want to see when we try to subscribe a particular observer to an event, what has to be done. And also later on, when there is an update from the subject side, what has to be done, right? That's something we're going to see. Okay, let's see. So now let me just, first of all, tell you that, let's see the structure for the test code. So we have a weather data over here, and then we initialize CC as a current conditions and app and observer. And this particular constructor here should somehow subscribe this particular app to the events. We'll see the code in just a moment. And then later on, when we try to update the measures for the weather station, let's say we want to update that to 15, 60, and 30.4. So what this set measurement as part of it, its body would do is it's going to publish the updates to the events, right? And the event is going to publish also the update to all the observers. Okay. Now, let me zoom out a little bit. Since now you pretty much get the idea about the code structure, let's see exactly what's going to happen. Okay. Now, I'm going to use orange over here to show you the first one. Let's say we talk about over here. Let's say we talk about this particular new current conditions line. Okay. Let's say this line over here, we are trying to basically create a new instance of the observer. Okay. So what we should do is we should really go to the constructor for that particular observer. And so this is exactly the constructor over here. So what does it really do? Basically, what it will do is it's trying to, for example, go to the corresponding events that it is monitoring, and then it try to pass the current objects and also some method handler. What's UT? UT is simply some return value from a library class, library method, which will simply return a reference to the method based on information like getting the class, which is the current class, and also the name of the method, which is update temperature, and also what's the other information about the method, right? That's about the subscription process. Okay, are we okay with this so far? And of course, if you want to look up the definition for those two events, you can see in the weather data class, we do have the declaration for these two events over here. Okay, one more thing to show you. And how does subscribe really work? You can go back to the event class over here. The way subscribe works is by simply putting whatever objects, the current object you're putting, and also the action, which is a method handle that I just passed. That's kind of the consequence of calling the constructor for a particular observer. You simply subscribe itself and also the reference to its update operation to the events. Yes? Yep. So this is where we call the subscribe, which is in the constructor of the observer, right? That's subscribe over here. Are we okay with that? Okay, yeah. Do we got questions or we okay?
No, you're just asking what.
Okay, no problem. Okay, so now let's look at the second one. Now, what happens if there's an updates? Okay, let's now look at another line. Let's look at this line over here, set measurements. Okay, let's say there's some updates over there. This will be better. Okay, we are looking at this line here. Let's say we want to change to 15, 60, and 30.4. Let's see what's going to be the effects. So up to now, the CC over there, which is the observer, has already been subscribed to the corresponding events, the temperature and the pressure events, right? So now, when I say set the measurement for the weather data, that means somehow the update should be published from the event to the observer, right? That's what's going to happen. But let's see how the consequence is going to be implemented. So we go from here, set measurements. If you simply go to the subject over here, which is weather data, right? If you go to the set measurements that we are calling here, let's see what it will do. It simply tells you what the new temperature, what the new humidity, and what the new pressures are, okay? And then it's simply just going to say, well, for this particular temperature, for example, what I would do is I'm going to call the corresponding events, let's say change on temperature. And then I'm going to publish the new temperature. Okay, so the publish is really done from the event side, not from the subjects. Okay? And now, how does publish work? Basically, publish will simply go to every subscribed observers and then call the method reference that we use, that we store when they subscribed. So that's why it's delay execution. Okay? If you now go there, and you can see that in the publish method for the events. So what we do is we go over all the listener actions hash table, which is like a collection of the observers. We simply go through all of them, and then we simply retrieve the delay execution of the method over here, right? We simply retrieve it using the identity of the observer. And then we simply call using the reference of the method to call that particular method. So this is now the timing for doing the updates. And then calling the updates with the context object being the observer and some arguments over here. And the argument here, if you look back, is simply just a temperature, which means we are trying to update the temperature. Guys, any question on the second part? Yes. Publish. Okay, the question is in the method publish, yes. Object, yes. I see what you mean. So basically, I can see where your confusion might be. Let's look at this. Each listener was simply just an object, which means this solution is so general, the current object can be any type. Now, when you try to call that, you can see listener is simply one of the arguments over here for invoke with arguments. If you go to that particular method in the Java API, it simply take any objects. So at the runtime, it's simply going to say, whatever object I have, I'm going to somehow cast that into that particular type internally, and then call the method. So for that part, you don't have to worry. No, you can register for as many events as you like.
For a particular event, you can only register one listener. For any specific.
No, it's you can definitely it's a hash table, so it can be more than one listener you want to register. It's a many-to-many relations we are trying to implement.
There could be more listeners, but each class, each application, as it were, you can only register one listener. At most one for each event.
I don't quite get it. Basically, it's a many-to-many, so it doesn't matter. So as long as you got the event objects over there, which is static, you can register as many observers you like on the one hand. On the other hand, you can also have as many subjects as you like. Okay.
What's the static type of listener here?
What do you mean, what's a static type of listener? Listener is simply an objects. What do you mean? What's the type of listener?
Sorry, I don't mean static type. I meant the dynamic type.
Dynamic type of listener can be anything. In this case, it can be current conditions, it can be forecast, it can be statistics. That's why, because every class in Java is a descending class of objects, so it can be anything. Guys, any confusion here? I think you definitely have to go into the code yourself, but I'm trying to just give you the big picture. Especially you want to focus on the two lines over there, the orange one, to see how things are being subscribed to a particular events. And for line number 2, used in pink, you want to see whenever there's an updates, how it is published to the events and then to the observer. Okay, so these are the 2 lines I want you to focus on. And, okay, any questions before I make a remark on this? Raymond, you okay? Yeah, I can. Yeah, I think do try to think about it and ask me a question in the class. I think that's the best use of your time. Okay, don't be shy. Okay. In publish, all right. Yeah, if you look at publish here, okay. So first of all, you can see action over here, right? Okay. Action is of type method handle. Method handle you can think about is a pointer to function that you learned in 2031. Okay. And the way we retrieve this particular method reference or pointing to function is by simply go to the hash table we have maintained for this particular events, and then simply give the identity of the listener, whose static type simply objects, which means it can be dynamically anything.
Dynamically right now is
Current conditions, yes, that's correct. And then once you get this action over here, the action itself is not about calling the method. It's only a reference to the method, so you can call that. That's why we keep saying that for the event-driven design, you delay the execution of the method. And how do you delay that? You simply store its reference somewhere. And then when you need to call that, you just call the reference. Okay? So now, what I really want you to see over here, maybe I can make a remark here for you. So when you actually put in the subscribe method over here, this is delay execution. Whereas over here, you simply retrieve the method and now execute the method now. Execute the stored method now. Okay, so there are 2 stages. When you subscribe, you don't really call the method just yet. But when you actually publish, you have to call whatever method reference you have stored. All right? Yeah?
You only subscribe once per observer, right?
For observer, yeah. For me being, let's say, for me being current conditions, I only have to subscribe myself to the, let's say, change on temperature event only once. So I'll be guaranteed whenever there's any updates from the subject side, they will first let the event know, and the event will let me know.
Okay.
Yeah.
So
That can happen as often as it's really necessary. Yeah. Okay. Guys, any questions about this? It's quite a new idea, I guess, so that's why I want to go a little bit slowly. Once you get this idea here, once I show you the IFO code, the ideas are completely the same. The only difference is they do have a cleaner syntax to help you with implementing the design. Okay? Yeah.
Okay, so Professor, you have the subjects and the observers.
Yes.
On the subjects, is it like the case where every subject is connected to every observer?
Okay, so you're talking about a connection between observer and subjects, right? Thinking this way, programmatically speaking, if you only look at, let's talk about client supplier, okay? If you only look at how we implement the weather data, who is the subjects, do you see any declaration of current conditions over here? Not really, right? The only thing you will see is the events. An event somehow is going to have some listener, which is of type objects in general. So the connection between subjects and observer are indirect. If you look at the diagram over here, you can see that if I want to go from a particular subject to an observer, I don't have any direct link. Unlike the case for the observer pattern, right? To go from subjects into observer, I do have a direct link to it. That's why the method execution cannot be delayed. When you want to update right away. On the other hand, in the case of the event-driven design, since now I have some intermediate point over here for the reducing the complexity of the runtime links, now when I try to subscribe this particular observer, I have to subscribe also the update operation here, but don't execute it just yet. It will only be executed whenever there's any update from this side. Okay, better? Okay. Okay, I think to really understand the code structure, try to recall this diagram always. Okay. Guys, any more questions before we see how we can do this in IFO? Okay.
Sir, is event-driven design only possible with the observer pattern?
No, I'm just trying to say for event-driven design somehow related to the problem we are trying to solve for observer. Of course, in general, let's say for ETF. ETF is not, well, ETF somehow, since every time you want to make a change on the model, you want to publish the updates to the output channel. That's something I'll talk about hopefully a little bit later in the course, but I'm trying to say focus on this property here, right? So when should you use event-driven design? Basically, every time if you got the concept about multiple subjects and multiple observers, and you want to make sure it's not so complex to have the many-to-many links, like what we did in observer pattern. That will be the case for using event-driven design, right? Okay. Guys, are we okay? Okay. If no questions, yeah? Well, in that case, if you got multiple, let's say multiple instances for the weather data, you can definitely instantiate them at the runtime. And then when you actually try to subscribe to, let's say for this, you may have different, well, in this case, of course, the fact that it's being static for the events, that means there's only one particular event, right? At the runtime, you can try to create multiple events as well. I'm just trying to make the example simple, just to understand. But you can try to modify that to suit your need, if you like. Huh?
It didn't really answer my question, but if we move on, maybe.
Maybe I didn't quite get your question. What's your question?
I think we.
Are you sure?
Yeah, I think
Okay, if you insist. Okay, guys, any more questions? Okay, so now the IFO side can be done rather quickly. Okay, because now we get an idea. Again, the idea really is you want to have a way to delay the execution of the methods. That's what you want to have, okay? So now, there is a keyword that you used to, that you have learned from day one from the tutorial, which is called agents. That's how you do it, okay? Let's see how we can do that, okay? So now, let's look at how we can do it in IFO. Okay, what I will do is, I'll show you some code over here. So now, again, let me show you every class for now, and then we'll show some architecture, okay? In the iPad. Again, we have an event class, and we simply have a generic parameter. We simply say every time if you want to call a particular update operation, you must pass an argument. So argument is simply like a G, just a generic parameter. It's not implementation detail, so you can look at the code by yourself. And then typically just a tuple. Okay, now let's have a look. Now I want you to compare line number 4 with the corresponding line that we had. Okay, line number 4 is simply just a collection of, now I say procedure. Procedure is just a predefined class in IFO library. What we have over here is basically just the same as what we did over here. You can see over here, let me just highlight it. We got hash table and method handle. Okay, before, for every entry in the hash table, we have to give the current observer identity, and also we want to give a reference to the method, right? That's what we did before. Now, everything, the information about identity for the current objects and the method reference, they are both encapsulated into a single class called procedure in IFO. Okay, that's all you have to know. Okay, and now, once we get these actions over here, what should we do? It will be very similar. So now, initially, we simply say create the actions list to be completely empty as before. And now, what about subscribe? Every time you want to subscribe, you're going to subscribe procedure, just a single procedure, as opposed to in the previous case, when you subscribe, you have to pass 2 information, 1 and also 2. Okay, so both of them have been encapsulated into a single class. Okay, so the procedure over here is going to include both the identity and also the method reference from the observer. Okay, that's subscribe. And then you can write some easy contract for that. Before you subscribe, you can make sure the action does not exist. After that, you can make sure it does exist. Okay, easy contract to write, and also easy implementation. Now the The only thing, again, is that you want to realize, well, whatever we do in procedure over here, we did do it in the Java code, but just in a more verbose way. Okay? And then we got publish. So now whenever we want to publish, you basically just want to pass an argument. And for simplicity, I'll say some G. Okay? And then after that, I think there might be a typo here. It should be arguments over here. Okay? It should be arguments, not G. Okay? I'll try to fix that. Okay? So now, how do we publish? For publish, it will be very similar to what we did before. You want to go over all the delay execution methods and call them. Right? To call them will be rather easy. What you got to do is you simply go across them, and then you simply actions, which is actions the item which will give you just a procedure. And then you can simply say call with the arguments. Okay, that's all you do. Okay? And then after that, that'll be it. If you compare line number 13 over here, if you look at line number 13, we simply say actions the item the call, right? We did something similar before. We simply say action dot invoke with arguments with the listener identity and also the arguments. It's basically the same idea. It's just that the listener and the argument have been encapsulated into a single procedure. Okay. Okay. Any questions about the event? Hopefully that's not too bad. Okay, so now as I said, procedure is really encapsulate both the context objects and the pointer to the update operation. Okay. So now the second one, the subjects. How do we define the subjects? Basically, we have to declare the events, right, as before. So the way we do it, we simply say, let's say we got temperature, we got temperature, we got humidity, we got pressure, and also we got some invariant for writing the correct limits as before. And now, let's say we declare one event, change on temperature, right? And then it's simply events, and then we simply say it's going to be a tuple of real number. Because when you try to update the temperature, you have to give what the current temperature is, just a single argument, right? So that's why I simply say it's going to be a tuple of a single real number, okay? And then for change on humidity, also you also pass the value for the humidity, right? So you say events with one single argument real number, and also change on pressure. Are you comfortable with line number 8 to 10? It is basically what we did previously in Java like this. We got events over here, and then we simply say change on temperature, change on humidity, and change on pressure. That's basically what we did. So based almost every line in IFO code, you can find some corresponding block of code in Java. Right? The ideas are really the same. Okay, let's now go back there. And now, what to do when we want to set the measurements? Basically, you want to update the measure locally, and also you want to publish the updates as well through the events. So what you would do is you want to make sure the new measure must be within the correct limits. They are still legal, and also update them locally. Now, what should we do now? Can you expect what to write over here? Yeah, we want to publish, but what should we call the publish on? The events, right? Okay, for example, we can say change on temperature the publish, or change on humidity the publish, right? You can see now in the observer pattern, the context object for publish is not really the events. There's no such intermediate level. Okay. Okay, so what we can do is we can say change on temperature and publish, and then we simply say just publish the temperature. Okay, and we can publish the pressure, we can publish the humidity, right? And every time you want to publish a particular measure, make sure you publish to the correct events, right? Corresponding events. Are we okay with the weather data? Yes, you first.
So change on temperature, like event, and humidity and pressure. So that passes a real number for the tuple because the event is the
correct. Yeah, the question really was, when we say events and then we say tuple real over here, right? So what that really means, you will see the corresponding declaration in just a moment in the subject observer side. It is to say every time, if you want to give some updates for this particular event, it's going to be just a single real number. In this case, remember every temperature is just a real number. That's why you put a single real number.
If we're only passing a single number, why do we make event take a tuple? Why can't we just make it take one number as the argument?
If you only got a single one, yes, you can do that. But I want to make sure to show you because tuple can hold more than one element in general. So this solution can simply easily extend it to a more general one. So that means update operation doesn't necessarily always take just one single argument. It can take maybe more than one, right? Yeah.
So for the square, for example, when you say dot publish square bracket, that's basically a tuple but with only one.
Correct. Correct.
So the other one is like
Yeah, correct. So again, you can think about what we're doing over here. When we say a tuple over here, let me just highlight it using a cursor. Okay, let's say square brackets with t. That means it's a tuple with only one element. But in general, you can pass as many elements as you like, depending on how many arguments the update operation is going to take, right? But you know what argument exactly you want to pass is completely up to your application. For this case, I'm just showing that since for updating the temperature, I only want to supply the latest temperature. That's why there's only one T over here, right?
I'm just saying like find that the other one's empty, right? How do I?
What do you mean the other one's empty? What's the?
It should be like square bracket T, comma, one more, and then comma, one more. Three arguments.
No, not really, not really. So over here, okay, you're confused with the following. So if you look at the arguments over here for set measurements, right? You see, for set measurements, you're updating T, P, and H, three things, right? But those three things correspond to three separate events. Each event is only responsible for one of the variables. That's our design. So that means when you want to publish to a particular event, well, when you want to actually let the event to publish the corresponding measure, you only have to give one value over here. That's why you pass T here, P here, and H here. That's why. Okay? Just tuples, yeah, exactly. Just tuples with the square brackets. Okay? Any questions? Yes.
Professor, those three features
Yeah.
in iPhone and also in Java, they should be private and export it to non.
What mean those? I mean the temperature, humidity, and pressure.
Yeah, those
Yeah, they should be. Yeah. For export status, you can definitely make it better. But I think the main idea really is you try to declare the events over here, and then you try to publish on the events, right? Okay. So now that's about the subjects. How does the observer work? Okay, let's see. What we should. So now let's remember, before for subscribing the observer, if you recall in Java, we had to somehow call something like this, right? You gotta declare something of type method handle and then pass so much information over there in order to subscribe, right? Let's see how you can do the corresponding concept in iPhone, okay? The way to do that, let's have a look. So now let's say we talk about current conditions. Okay, over here we got make weather data. Okay, now when you first create a weather data current conditions, what you would do is I want to subscribe to this particular event. So I would say WD, the weather data, dot change on temperature, right? I subscribe to it, but what do I subscribe? I used to have to pass both the current observer and also a pointer to the update operation. But now everything is encapsulated into a procedure. So how do you make a procedure? The way to make a procedure, which is a pointer to function, you just have to say agent update temperature. That's all you have to say. Okay? Now, remember the keyword this. In the case of Java, it's called this. But in iPhone, it's called current, right? You can think about update temperature as if we said current.update temperature. That means the current will also be stored implicitly. It's just done automatically for you. Okay? Now, so we subscribe to the update on temperature. Also, we subscribe to change on, I think this should be change on humidity. Sorry, that's a typo. Okay, should be changed. So change on temperature and also change on humidity, right? The two. Okay, and then we got other things to worry about. Okay. Are we okay with the subscription over here? Okay. You can see it's the same idea. It's just that the way we do it is just neater. in iPhone. Yeah.
This is current conditions. So the other two, I think was something with forecast.
Yeah, forecast and also statistics.
Right.
Yeah.
So they might have like also temperature in them. I don't remember.
Yeah.
So if you do,
Yep.
if you subscribe to your temperature,
Yep.
agents.
Yeah, exactly. So now, okay, the question was, let's imagine how do we implement, let's say, forecast, okay? The forecast only worries about the pressure, okay? Let's say we have a class forecast over here, and then we'll simply say wd.change on pressure dot subscribed, and the agents, and there was an update pressure. That's what we would say, right? And now, there are more than one observer who's observing the pressure. For example, statistics and also the forecast. So how can they be handled? Very easy. If you look at the previous code over here, if you look at the events, I want to show you too. If you look at the events, you can see for the event, we simply got action, which is simply a linked list, which means one of the actions will be from the forecast. One of the other actions in the list will be from the statistics, right? So there's no confusion here. Yeah. Okay, are we okay so far? Okay. All right, let's now go on and see how we can use them. Okay, finally, so that's about the observer over here. You just have to know how to do subscription. Let's now move on. So now one thing to note, whenever you say agents update temperature over here, it's as if there's a current like this qualifier over there. So that would be stored as well. Okay, now finally, we have a weather station over here, right? For weather station, it's going to be very similar as before, but now what's going to happen will be a little bit different. Okay, things will then be done a little bit differently. Okay, so now we say we got current conditions over here, so we got weather data, some measure here, and then first of all, when we say cc.make wd, right? What's going to happen, which will be the same as before, we're going to subscribe this particular observer, which is cc, into the events, right? Depending on how many monitor variable it has. In this case, current conditions should be the humidity and also the temperature. So these two events. Okay, I'm going to show you on the iPad to review. And also, what about set measurements? Set measurements simply means there's an update from the subject side. So that means we should really call the corresponding events, especially for, let's say, call the corresponding events for pressure, change on temperature, and change on humidity, and make sure they publish the updates to all their subscribed observers. Okay, that's what you would do. Okay, now, okay, that's pretty much the layout of the code. I want to show you one more thing. I want to show you exactly what these two lines will do. Okay, these two lines, subscribe and publish. Let's see. Okay, so now this is event-driven design iPhone. Let's see how we can do it. Okay. Now, first one, let's see over here. Let's say we got create cc.make. This is when we create the observer. So what's going to happen is, let's go to the make feature for the observer. So this is the observer over here. Okay, and then we simply go to, under the make feature over here for the observer, we simply go to, again, this should be pressure. Oh, sorry, should be pressure. Oh, humidity. I'll update that. Let's say for here, we simply go to the corresponding events for changing the temperature, and then we say subscribe. And let's review what a subscribe does. The subscribe simply exists in the event class, and subscribe will simply just add whatever action it is of type procedure, which will consider the method pointer and also the current objects for the observer, right? And remember, actions is simply of type linked list. Okay, we simply just add it, just extend. Okay, so what do we pass to subscribe over here? We simply say update temperature is a feature for updates, and update temperature is simply defined over here. Update temperature. Given some temperature, I'm going to just assign my local temperature to be that particular update value, right? And now, it would be a huge difference when you say subscribe and you say update temperature versus when you say subscribe. And when you say agent update temperature, it's a huge difference over here. What's the difference between these two? Let me number them. 1 and 2. Okay, 1. For 1, what does it do? Aha, if you don't think that will compile, why not? It's a procedure, right? And then? Yeah, so basically you got to think about UT over here, update temperature over here is simply just a procedure over here. So you're trying to make a procedure call as a method parameter. A procedure does not return anything, right? So that's not going to do whatever you expect to do, okay? So this one here, on the other hand, you're saying that I'm not trying to call this particular procedure. I'm only trying to use the agent function to get a reference to that particular procedure. So you can call that later. That's how we implement the delay execution. Yeah?
Update temperature is called in events.
It will be called in the events, yes. It will be, yeah. Oh, I should make it right away. So how is this particular store execution going to be called? It's delayed, but it will be called whenever you go to events over here, whenever you call publish, right? When you call publish, you'll simply go over all the actions, and then actions.item will simply be of type procedure. And one example procedure can be when you simply say agents update temperature, right? And then once you get it, you'll simply say, now I want to call this particular procedure right away with this particular arguments. Okay. Okay. Now let's go a little bit further. Okay. So that's about the event side. Okay. Of course, don't forget you actually declare the two events over here in the weather data. Okay. Let's now look at this line here. So we are done. So now what about the set measurements over here, right? That's the second line I want you to pay attention to. What we just talked about is how you can subscribe from observer to the events. But now how do we publish from subject to the events? How do we do that, right? So now whenever you say subject is WD, weather data. When you say weather data.set the measurements, let's go to set measurement right away. Set measurements under weather data, the subjects, and if you go to set measurements over here, we want to update to a particular T, P, and H, right? And now, what should we do? Well, we're going to update the local temperature, local pressure, and local humidity first. And then we're going to publish these measures, the latest one, onto the events, okay? What we do is we simply go to the events, for example, change on temperature, right? Change on temperature has a feature called publish. And let's look at publish. If you look at publish here, you're going to take some arguments over here, right? And the arguments we are passing over here is simply just T, which is the real number. Just the temperature, right? So whatever the new temperature it is, we're going to pass that and then go to publish. And what the publish will do, again, go over all the delay executions over there and then go to each one of them and then simply call with this particular arguments. In this case, it's simply just T, right? So that means we simply got T over here. And then that means we got T over here. Just the temperature. Yeah? It's a typo, yes. Yep, you know what? That's why it's so bad to make a typo. I think what I meant to say here is arguments. You can see that argument is one of the generic parameter over here, and then it has to be, so this is so-called constraint genericity. And in Java, you also got something similar. Well, very briefly, in Java, you would say, I want to have a generic parameter, whatever name I like. You can say that one extends a particular class. So this dash arrow is doing exactly that. You simply say whatever argument type you want it to be, it must be a subclass of tuple. Okay, it's simply that. Let me say one more thing. Over here, you can see that the arguments over here has to be of type arguments, and which has to be a tuple. And we're doing exactly that. If you look at how we do the publish, we say publish over here, and then we give a tuple which contains just one single pressure. But in general, you can pass as many arguments as you like in the tuple. You mean subscribe or?
Yeah, when you subscribe, update temperature feature, it has only one parameter, right?
For simplicity, there's only one. For simplicity,
But
yeah.
it's given a tuple, which could have 3 arguments. So does it always take the first value?
No. Over here. So over here you can see. Okay, let me just say again. Over here, let's have a look at this. So you got, let's say, change on. Let's say change. Let me see if I do have that. Okay, good. How about this? Change on humidity. Okay. When we say publish, and then we pass p over here, right? A tuple, right? So let's say we go to the publish feature over here, right? And then when we say actions.item.call, and then over here we're going to have the pressure over here. That means whatever actions that we're going to call is going to be expected to have only a single argument. In this case, yes, it is. Because, one moment, because over here you can see that change on, you can see, for example, change on humidity over here is simply just a feature that takes exactly just one argument, so it will be used. In this case, if you pass 3 arguments, the other 2 will just not be used. So what's the point then? Because you only expect 1 argument over here, right? Yeah. Okay. Okay, questions about this design here? We're basically talking about the same idea, the same architecture, but now we think about how we can implement it in 2 different languages. Okay. But as far as design is concerned, you just neater syntax to be supported in iPhone. But of course, if you want to implement it in Java, you can still do it. Okay. All right. Any questions about this before I do a final slides on this pattern here? So think about what we really have done for this particular lecture. So we talk about how we can solve the weather station problem, right? Initially, we start with there's only a single link from weather data, from each observer, like a app, to the weather station, right? That's the very poor design, okay? And then we started with the observer design, where the runtime structure is too complicated, right? Because you got a very complex structure for multiple subjects and multiple subjects and multiple observers. And then we move on to the event-driven design, where we can reduce the complexity by adding the concept of events. Okay, of course, you gotta review the code and the slides, right? Hopefully the big picture is clear to you. Guys, any questions for me before I move on? Any questions? We okay, right? All right. Okay, a final slide I would like to refer to you. Basically, this slide here, again, tells you, for example, in the event class, we had to declare by including objects and method handle in the case of Java. But in the case of iPhone, we simply say procedure, right? Just some more support on the library. And then if you want to subscribe to particular events, you have to do so much coding over here to get a method handle, as opposed to simply use agent, okay, in iPhone. Okay, that's the final comparison. Okay, it's just saying that for the event-driven design, you just have more direct support for iPhone. That's it. Okay, but you should also know how to do that in Java as well. All right. All right. Sorry?
What about lambdas in Java 8?
Lambda expression?
Yeah.
Lambda expression, it might work. I'm not sure how to do it. You can try and then let us know. All right, good. Yeah, basically the question was, what about the lambda expression that's introduced in Java? Basically, lambda expression, if you have heard of it, is a way to also have delay execution. But I'm not too sure how general it is for you to actually define a method anonymously using lambda expression. Okay, but if you can do it, sure. That might be just another alternative to using method handle. It might be. Okay, but idea is really the same. Okay, any questions about this lecture before I move on to a new topic? Okay, we still have some time for at least the introduction for this new topic. Okay, now, the new topic over here is about, since we talk about design and also implementation, the very idea about having specification like your contracts and also your implementation is we can now define a very precise notion about correctness. So what does it really mean for your software to be correct? That means given the specification you have, the contracts, and given the code you have, which can be arbitrarily complicated, how can you be sure that you can prove that your implementation is consistent with your contracts? So we are showing you this lecture here. You want to do some little bit manual proof to get some idea. Okay? Now, let's do some warm-up. Okay? And the lecture is going to be a little bit logical, but we talk about all the logical background when we talk about subcontracting. So many parts will just be a review of the background. Okay? First of all, remember we talk about what does it really mean for a precondition to require less than another precondition, right? We talk about predicate implies another. So that's how we check. Similarly, we also talk about what does it really mean for a postcondition to ensure more than the other postcondition. Let's keep that in mind. Okay, that's something that we're going to say. Okay? Now we're going to have a very similar notion over here. So let's not worry about precondition and postcondition. Just in general, any assertion or predicates. Have you actually learned about the notion between weak and strong in 1090 or 1019? I'm not too sure. Maybe, yeah. Okay, let's just review very quickly. But it's very easy. So now, again, we can describe each predicate as a list of satisfying values. So we can say that x larger than 3, we simply got all the values, the set of values that's larger than 3, starting from 4. Okay, it's an infinite set, conceptually. And also we got x larger than 4. Okay, let's say we got these two predicates. Okay, apparently you can see that the first set over here, the set corresponding to x larger than 3 is strictly larger than the other set, which correspond to the predicate x larger than 4. Okay, so now we can now define some notion about a predicate being stronger or a predicate being weaker. Okay, the principle is easy. Whenever you got two predicates over here, if the satisfying values, let's say here, over here, let me just put it on the iPad. That'll be easier. Okay, if I go to this particular example, let's say x larger than 3 and x larger than 4. Okay, if you think about the relation between these two predicates, the satisfying value. So we know that if these are all the values for x larger than 3, okay, starting from 3 and 4 and 5 and 6 and etc., right? So now, the set for x larger than 4, would it be smaller or larger? Smaller, right? We're excluding certain value, right? What are we excluding? 3, right? Good. So what I should draw is something like this. Let me use a different color. That means this set over here will be the set for x larger than 4, which is strictly smaller, right? So now we'll say that typically for the set that's at least as big. Okay, so now how do we define the notion between these two predicates? Okay, let's say this is predicate, let me write it out. There are two ways for you to say that. You can either say x larger than 3 is weaker than x larger than 4. Weaker in the sense that because it is weaker, so it can allow more values to be accepted, right? Or on the other hand, you can also say x larger than 4 is stronger than x larger than 3, right? Stronger versus weaker, if they're symmetric. Okay? Now, how do we, so you don't necessarily want to think about in terms of sets every time. You can also use implication. Okay? So now let me just say, put it here. So when I say one is weaker than the other, so what I really meant by that was x larger than 4, it implies x larger than 3. Right? Are we okay with that? That means if it's guaranteed everything in this set should be also everything in this particular set, but not vice versa. Okay. So we say that in this case, you should really be able to decide which one is stronger. Okay. Are we okay with this notion here? Just stronger versus weaker. Again, if you want to decide whether one predicate is weaker than the other, you can first think about which set is actually bigger. The bigger one should be the weaker predicates. Or you can simply try to prove certain predicates. So when you can prove P1 implies P2, if that's something you can prove, so this will be the weaker one, and this will be the stronger one. Okay, that's the rule. Everybody okay with this? Okay, I suppose that's just a review. Okay, having this in mind, let's go on. Okay, that's about stronger versus weaker. Oops. Hopefully you didn't see that. I was going a bit too quick. So now, what's the weakest assertion? Well, weakest means, which means you will allow all the values, right? Okay, that's quite obvious, it will be true. Okay, now, and this slide here is just about math, but we'll try to link that to your contracts, but every contract is also Boolean predicates. And what will be the strongest assertion? Strongest assertion means it's so strong that the corresponding set will just be empty. False, right? Okay, that's good. Now, in decide by contracts, all right? So now, you can think about, let's just get used to the notation. When I say an invariant is weaker than the other, so what does that mean? That means this particular weaker invariance can allow more values of the attributes to be legal, right? For example, let's say if you consider balance larger than 0 versus balance larger than 100, okay? Would you agree, first of all, balance larger than 0 is weaker, right? Because it is weaker, that means it allows more object states to be legal. Okay, that's about invariance. On the other hand, when you say, I'm just going to put something here on the iPad. Okay, over here you got invariance, balance larger than 0, number 1, and number 2. Balance larger than 100. Let's say we got these two alternatives, right? First of all, we know that 2 implies 1. Agree? That means 2 over here is a stronger class invariance, whereas this is a weaker one. Okay? That's testing our notion. Okay? That means if you try to think about what would be the corresponding legal object states at the runtime for each one of them. Let's say for number 1, let's say for number 2 first. For number 2, it has to be all the object states where the balance is larger than 100, right? It can be 101, 102, 103, and etc., right? On the other hand, what about the second one? Oh, sorry, the first one. The first one, the balance must be larger than 0 only. That means, in this case, it could be 1, in which case 1 wouldn't really satisfy this predicate here, right? So that's why it's not included. And also it can be 2, can be 3, and all the way to 100. Yes, exactly. Yeah, yeah. So here, when I say stronger, you can think about stronger simply means stricter. Yes, yeah. And when I say weaker, that means more tolerant as well, right? Okay. Okay, that's about weaker invariance. Though, so what does it really mean when you say a precondition is weaker, right? Weaker precondition simply means more input values can be accepted. Do you think that's being more tolerant on the clients or more tolerant on the supplier?
More tolerant on the client.
More tolerant on the client, right? Because that means the client can pass more input values in order to call this particular feature. Well, in that case, that means supplier has to deal with more input values than a stronger precondition, right? Okay. Okay. Similarly, if you say, in this case, a weaker postcondition, right? A weaker postcondition simply means the supplier is actually can produce more possible output value. They're not so constrained for a particular set. Okay. Okay, so these are the concepts you want to get used to. Right? Okay, so now let's do some example over here. Okay, given that we know about weaker versus stronger. Example number 1. So over here we got a complete program over here. Let's say we only got a feature called increment by 9, and we got an attributes. So we got contracts over here. The contract are simply the precondition, postcondition, and also we got an implementation, just one line. Okay. As far as you can see, do you think this program here is correct? Okay. Anybody want to give me one counter example where things might go wrong? Yeah. Let me just. Anybody from here want to try? Yes. Let's say this. Let's say now we want to make, let's say the post condition is okay. So let's say this. Let me guide you a little bit and then I'll take your, so let's say this. Let's say this post condition is really something we would like to achieve. We really want the I to be strictly larger than 13. Let's say afterwards. Let's say we really want to do it. Okay? So now, is there something wrong with this precondition over here? Is it too weak or too strong? Be careful. If you say the precondition over here is too weak, you are claiming that it's accepting more values than it should have, right? For example, what values has it accepted mistakenly? Right? Good. Okay? Now, basically what we want to conclude is something like this. Given that we want to keep this post condition, let's say there's nothing wrong with this post condition over here, right? And we are claiming that this particular precondition over here is too weak. It's too weak simply because if you think about the value where I is simply just 4, for example, right? When I is equal to 4, it's going to satisfy I larger than 3, right? Which means that there's no precondition violation. And you will simply go to the do body over here, and the increments I will be simply I plus, I will just be whatever this is. So 4 plus 9, it will just be 13. And 13 is not going to satisfy this particular post condition, right? Okay? So it's not going to work. Okay? So from this example here, what I hope you to pick up is if the post condition is fixed and also the implementation is fixed, how do you know if the precondition is too weak or too strong? Okay, that's my concern. Yes?
What if I equals 5?
I equals 5?
Yeah.
I equals 5 is okay, yeah. The question was, what if I is equal to 5? If I is equal to 5, let's try. If I simply equal to 5, 5 larger than 3 will be true, no precondition violation. And then 5 plus 9 will just be 14. So 14 larger than 13 is no problem, so there's no post-condition violation. But the problem is, this particular precondition does allow I being 4. And I being 4 will give you a post-condition violation. Right? So that means it allows certain values that shouldn't be accepted. Right? Yeah, I'm just wondering, yeah, you can change that to something. I'm just trying to say for this particular example here, we want to know at least the precondition is too weak. It should be stronger. How much stronger should it be? That will be some discussion later. Okay? Okay, let's do another one. What about this one here? Do you think, first of all, do you think the precondition is okay? Okay or not? Okay, for example, what would be the smallest value that can be accepted for the precondition? 6, right? So 6 plus 9 will be 15, 15 larger than 13, no problem. However, I would say potentially, I'm not saying necessarily the case. So for here, I would say potentially it may be too strong, meaning that it's filtering out certain value that wouldn't actually cause a post condition violation. For example, give me a value. 5, right? For example, when I is equal to 5, somehow 5 larger than 5 is going to be a precondition violation. is going to be a precondition violation. But I plus 9, which is 14, is still larger than 13. There'll be no post-condition violation, right? So that means it might be a little bit too strong. It might be. Okay? It's not too weak, but it might be a little bit too strong. Okay? That's the second concern. So now, from these two examples, it seems like for easy example, you can easily just observe by your eyes to see whether it might be too strong or too weak. However, in general, for complicated programs, how do you determine if a precondition is too weak or too strong, given that the postcondition and implementation are fixed? And the implementation may even contain a loop, right? So now that means we need a systematic way to prove it. Okay? That's exactly what this lecture is about. Yeah, somehow, yeah, vaguely speaking, a little bit vague, okay? We'll make it precise a little bit later. So informally, you want to prove that given a precondition, if it is satisfied, and then you try to execute the body of the implementation, is guaranteed the postcondition should be satisfied. But how do you prove this formally? And also, you want to make sure the body of the implementation terminates. What if you got an infinite loop? Right? There are issues like this you have to take care of. Right? So we talk about two issues over here. Termination of the body of the implementation, and also if the body of implementation terminates, is a guarantee to establish the postcondition. So these are two issues over here. Okay? Questions? Okay? Yeah. Well, for the infinite loop, that means when you want to prove if a program is correct, there are two things you want to prove. Number one, you want to make sure the body of the implementation will terminate. Otherwise, you will never produce the output value, right? That's number one. So we're talking about separation of concern. Concern number one, it terminates. Number two, if the program terminates, given the precondition it started with, is a guarantee to establish the postcondition. So there are two issues here. We'll talk about both separately. So that means you got two separate proofs to do. Okay? Yeah. All right. Let's go a little bit further. Okay? Now, let's see what we can do. Okay? Okay, let's talk about correctness in general a little bit quickly. Okay? So now, correctness is really a relative notion. So that means given the implementation, how do you know if the implementation is correct? You have to be given some specification. And in our class, since we talk about design, so you do have the specification, which is the contracts. Okay, precondition, postcondition, event invariance. Okay, so now, what we're gonna do, let's do a preview. We might do just a little bit today, just give you some example, but we'll get into the formal parts for the next two lectures. Okay, what we want to do is to say, now I'm gonna give you one example here. So we got two examples over here. Okay, so now let me show you what we're gonna do. So here we got orange part are the contracts, and also we got a green part being the implementation. So these are the three pieces of information you will need to prove correctness. So now, let's say I give you a fragment of code like this. I say now prove formally that this program is correct. How would you do it? Okay. Basically, what you have to do in the next two lectures is to say somehow given this, I'm going to turn that into a notation like this. Okay. The syntax looks like that. Very easy syntax. I'm going to say curly brackets. Start with. And also curly brackets over here, and and then also something in the middle. Okay. So now for the first pair of curly brackets, I'm going to copy the precondition verbatim, I larger than 3. For the second pair of brackets, I'm going to copy postcondition verbatim, I larger than 13. Okay. And then what's going to be inside? Well, the implementation. Whatever implementation I have, which can be multiple lines, in this case just one line. I say I is assigned to I plus 9. It looks just the same, right? But it's in a form that can be manipulated. Okay, now let's go a little bit further. And given this is so-called a Hoare triple. Okay. So remember we talked about this person here, Hoare? So when did we talk about him, if you remember? Anybody? A quicksort, yeah, but we didn't really teach a quicksort in this course, did we? I said that, yeah, but when did we say that? Null pointer exception. So Hoare is actually the inventor of null pointer. Okay, just remind you about it. All right, so anyway, it's called Hoare triple. The name is not really important, but you're expected to manipulate that by the exam. Okay, I'll show you. Once you get a syntax like this, so this thing over here is treated as a predicate. Okay, how exactly the predicate should be interpreted, we'll go into details a little bit later. But for this predicate here, if it's a predicate, that means you can try to prove it is true or false, right? If you can prove that this particular predicate is true, that means the original program is correct. If you can find any counterexample to show that this predicate might be false in some cases, that means the original program is not correct. Okay, as easy as that. Similarly, you can also do, for this one here, you can also say, I got curly brackets over here, and then I'll put I larger than 5, I is assigned to I plus 9, and also I larger than 13. Okay, just like that. Okay. Now, again, we're going to prove to see if this will be either true or it can give some counter example. Either way. Okay. Now, let's just go a bit more, and then we're done. Okay, that's something we're going to do. How much time do we have? 3 minutes? Okay, you know what? I'll let you go earlier today. Okay.